All right, today's lesson, Mr. G Math, right, coming at you live, 7202, is on integrating logarithms. This is going to be a little more involved, and some algebra skills that you might have forgotten we're going to review right now. Are we together? Say we're together, right? We're listening. You promise? We got our packet out. We're in the right spot, listening and so on. So, differentiating and integration, obviously, inverse relationships, right? So, if the derivative of ln, the absolute value of x, is 1 over x, then if you integrate 1 over x, what do you get? Ln x. Now, this leads us, do you remember when we do the anti-power rule, and I said, what would happen if you had x to the negative 1? That means the same as 1 over x, right? And if we did the anti-power rule, we would add 1 and then divide, and it didn't work, right, for negative 1. Because if you add 1 to negative 1, you get 0, and then divide by 0, you can see how it goes to garbage, right? So x to the negative 1, or 1 over x, that's a special situation, right? And when you integrate that, it's not the power rule, but it's a natural logarithm, right, when you integrate it. That's a big, big thing that's going to keep coming up and up, right? So, to recognize that x to the negative 1 is not a power rule. If I said y equals x to the negative 2, and you integrate, then you would add 1 and then divide, okay? So, this exponent makes it special. And if you tried to apply the power rule, you should, stop yourself, right? And go, hey, that's not right. What do I need to think about? All right. And then it said, if you integrate, what did I say again about the numerator?
It's the hook.
What? I didn't say that before, I don't think. All right, so the numerator's the hook. So if there's a hook involved, where would you find that hook? In the numerator. All right. And if we want to set up the hook correctly, we're going to set up the numerator, then undo it right in front as necessary. All right, so here are the rules. You can see them, right? Let's look at number 1. Oh, and it says, although it's true for both, right, why do we always use the absolute value? Do you know why? No. So this, when we integrate, we're not going to use, every time we integrate with ln, integrate, what are we going to include inside? Bars. Why does it need the absolute value bars? All right, I'm going to tell you. Look at this function, negative 3 over x, right? You know when you integrate, it's going to be ln x, right? But why do I need the bars? The reason is this. What's the domain of negative 3 over x? Except what? 0, correct? If I just go ln x, right, what I'm saying is the domain really is all positive values. Because inside a logarithm, you can only have positive numbers, right, for the domain. But if you put the absolute value bars, what are you saying? It can be negative, it can be positive, but not 0. So why do you need the bars? To protect the domain. Why do I need the bars? Protects that domain. That means the domain can be negative and the domain can be positive if you put bars there. No bars? It can only be positive. Okay? So let's do this. So when we integrate, what are you going to put inside a logarithm? Bars. What are you going to do again? Bars. The numerator's the? Oh, good. What's the hook here? Negative 3 is the hook. All right, so how am I going to integrate this? So we can actually use this hook, negative 3. We can undo it, but really any constant can be written in front of the integration. And then how do you integrate 1 over x? And what are you going to remember? 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 So not just the bars, but the... Yes?
Chess.
Oh, it's all right. I got patience sometimes. Yay! Look at that. Gardy has a little pun. Candy bars. Get that? Good job, Candy. Good job, Gardy. I said good job, Candy. All right, here we go. See, do you get it? The bars guard. Oh, wait. Here we go. It all comes around. Here we go. Number 2. Let's integrate this. So, in this example, I want you to look at the denominator, right? The hook would be the derivative of the denominator. What is the derivative of the denominator? Where does the hook belong? In the numerator, right? What do I have in the numerator? So, I need it to be what? Why do I need it to be 2p? That's the hook, right? The derivative of the denominator gives me the hook. But, for it to stay equivalent, what needs to be in front? 1/2 undoes the 2. Now we're good. Now you just follow the rules. Don't worry about the hook, right? We've already taken care of the hook. What's the rule here? 1/2 in front, ln of what? P squared plus 1, and? Now, believe it or not, here's an example where you don't need bars. You know why? It's never wrong to put in a bar, so I'm not going to tell you to overthink it. But just because we're here, why do you not need bars here? Because p squared means, right? So it takes care of that essence, that if you had a negative number, it will be positive. A positive number would be positive. So the domain is already protected with the squared compared to the bars. Okay, 3. And I'm going to rewrite it properly. How do I find the hook? The derivative of the denominator. What is the derivative of the denominator? 3t squared minus 2t. Is that the same as what's there? What do I need in front to make it equivalent? No. I know. I know you're on the track, but you thought too quick. You didn't really think about it. What do I need in front so they stay the same? It's not 1/3, but because 3 times 3 and 3 times 2, right? Now, what's the rule to integrating? Don't worry about the numerator. This one I need bars, right? Because t cubed. And then? I do. I need the candy bars. I'm going to use that now. Are we okay? We got practice, right? But we good? Okay, let's keep going. It says when integrating a fraction where the degree of the numerator is bigger than the degree of the denominator, or the same, you will have to use your friend, long division, to split the fraction. So, when you look at this fraction, what's the indicator that I have to use algebra before I can integrate? It's the degree. What's the power and the power, right? Are they the same? Is there more power on top? Then you have to divide. Notice the other examples, right? Because when you take the derivative, well, you can see, right? There's no way to manipulate it, right? To make it to what it needs to be. You don't remember how to do this. So we're going to do it together. See, you don't have a teacher that goes, I can't believe you don't remember how to do this. I guess I'll have to do it again for you because you forgot from a year ago. No, and that's such a good question. So the good question was, when I taught you division of polynomials, if I taught you last year, right? We often did synthetic division to divide, right? The problem is the divisor has a degree of 2. You can only use synthetic division if the divisor is linear. Okay? This is a big emphasis on the AP exam, is to know that you can do long division. They think that you guys don't know. All you do is synthetic, that if you have to do long, you can't. So there's questions that force you to do this. It's been a new emphasis. They tell calculus teachers that this is one of the new emphases that they're going to put on the exam, that they're going to make you do long division. So here we go. How do I do that? Well, x squared goes into x squared how many times? If you don't know, you take the first term divided by the first term and get your answer. Got it? So multiply 1 times x squared, 1 times 2, and then what do I do for long division? Oh, and what should I do? Duh. Make sure like terms are underneath each other. If you like, you can put a 0x there. It doesn't matter. But make sure like terms are underneath each other, right, when you subtract? So when I went 1 times 2, it needs to go under the other like term. X squared subtract x squared. Done. Negative 4x subtract nothing. And then 2 take away 2. All right, let's go back. I need the ability to write this answer down. You ready? So what we had has now become, first of all, what's the answer on top? 1, but I have a remainder. How do I write down that remainder? And you can go plus if you want, but it's negative 4x over. So the remainder is what? Negative 4x. What do I put in the denominator for the remainder? Yeah, right? The divisor.
Yeah,
Thank you, sir.
I know where you're going to do that.
All right. Whenever you see adding and subtracting, you can easily separate it, right? So this is the integrating 1, simple. And then integrating negative 4x over x squared plus 2. Thank you. He's actually not here. All right, so the easy part, integrate 1.
0. Oh,
Maybe it's not easy. X. What's the derivative of x? 1. Okay, that's easy. Okay, next. What will this integrate to be?
x squared plus 2.
Do you recognize it's going to be a logarithm? Now is the denominator more powerful than the numerator? What's the derivative of the denominator? Can I write that up here? Remember, the hook goes in the numerator. What number in front will make it equivalent to what it was before? Beautiful. And yes, the plus and the minus can make that a minus as we simplify. So now we're done. What? So x plus and minus just makes it minus 2 ln absolute value of what? And do I actually need the absolute value in this case? No. Is it wrong to put it in there? No. So just do it. Why overthink? Last thing you need to do is overthink something you don't need to in calculus, right? There's enough stuff you need to think about. Just put in the bars. All right, example 5. When integrating functions that contain logarithms, you usually want to think about doing a reverse chain integration where u equals ln x or something that contains ln and that the hook is 1 over x. Let's see what that really means so you can understand it. Notice that normally when you see a fraction, I'd say, what's the derivative of the denominator? And it is 1. Can you see it doesn't fit the structure of that? But instead, look at it this way. Do you see the ln x? That's an indicator that ln x is actually your u, and your hook is actually what's down here at the bottom. It got flipped around. I can show it to you better this way. Do you know that they are equivalent, what I just wrote down? That ln x times 1 over x means the same as that. Do you notice how I put parentheses around here? There's a reason I'm going to show you in a second. So first of all, what's the derivative of ln x? Do you see how the hook is included here? So the derivative of ln x is 1x. So here's u, and here is u prime. I don't need to do anything to manipulate. It's ready to integrate, right? The hook is right. There's nothing to change. how do I do this then? Well, how do I integrate ln x? Think of it as the anti-power rule. What exponent don't you see on the ln x? So what's the anti-power rule? Relax. You add 1, and what do you get? So parentheses, and then divide by, and the candy. What? So sometimes you have to think, is the hook really in the numerator? Like, am I really integrating ln x? In this case, I'm not really integrating ln x, right? It's really the anti-power rule, and the hook gave me 1 over x. And what is the anti-power rule? Add 1 and then divide, right? What's the difference between that and way at the beginning here, like at number 2, when you took the derivative, can you see how the structure matched? P squared plus 1, right, gave you 2p. That I can work with. When I look at this fraction, the derivative of x, right, I have to look at it differently now. It's now been flipped around, right, what u is in u prime. All right, look at example number 6. You ready? Okay. If you can see this, do you see how the expression contains ln? And can you see outside? I see 1 over x. I know it's hard to see, but those are indicators. Ln and 1 over x. That's because they're derivatives, right? They're hooks. I'm going to write this differently. I'm going to write it, instead of 1 over, I'm going to write it as 2 subtract ln x to the exponent negative 3. Will you allow that? And 1 over x, I'm just going to write down times 1 over x. Why do I write it this way? Can you actually see u and u prime when I write it this way? So often, right, a fraction needs to be written as the negative exponent so you can see u and u prime. What's the derivative of 2 subtract ln x? Close. So what do I need in front to keep it equivalent? Right? Now, how do I integrate? Don't worry about this. It's now just the anti-power rule. What's in front again? And what do I do? First, you add 1, which would be what? And then what do you divide by? Okay? And yes, remember the candy. The negatives really make this positive. Not necessary for free response, but might be necessary for multiple choice. You might even see a 1/2 in front, right? If it was multiple choice. Turn the page. Oh, don't forget the candy. One more left. Do you notice this lesson is really working your pre-calculus skills? Yeah. That the calculus skills are relatively straightforward, but it takes good algebra to get to the straightforward calculus. Yes? All right. The first thing I should look at here is root x subtract 1. Look at the structure of it. It's okay to say, wait a second, I'm going to write that as x to the 1/2 minus 1. I could also write that as x to the 1/2 minus 1 to the negative 1, right? It's okay to rewrite it in a way to try to see what direction I need to go. If I took the derivative of the denominator, would that help me with the hook on top? No. If I took the derivative of the base, do I see the hook outside that can help me do the anti-power rule? No. This is going to require a u substitution. So I tried one way. Wait. I tried one way. What's the first way I look at when I see that fraction? The derivative of the bottom, do I see it? No. Write it, instead of as a fraction, as a power, right? If I take the derivative of the base, do I see the hook? No. Now, my last scenario, what am I going to do? U substitution. So in this case, u is going to equal only the square root part. Do you remember u substitution? Maybe, right? So you know what u equals. I need to know what x equals. If u equals the square root of x, what do I do to both sides to undo that to know what x equals? So u would equal to what? Or x would equal to u squared, and then take the derivative. So u squared would be 2u du, and x would just be 1 dx. And we're separating the du and dx so we can do a substitution right now. So go back into the problem. Where I see a root x, what am I going to put in? What does root x equal? U. Where I see a dx, what's going to go in its place? No? So now let's put it together. If you like this problem, you are showing off that you love calculus. What do you notice? Do you notice I went 1 times 2u and put it together? What do you notice about the power on top and the power on the bottom? The power is the same, right? If the power is the same, or if the top is bigger, what do we need to do? Long division. As I said, you love this problem, you love calculus. Thankfully, this won't take long, but we're just being able to write the equation differently so I can actually integrate it. Can you tell me u goes into 2u how many times? And then you're going to multiply. So 2 times u is, and 2 times negative 1 is, and if you like, you can put a plus 0 above it if it helps you figure out the remainder. What's the remainder here? 0 subtract negative 2. Let's go back to the problem. Now we're going to write it. What was the answer again? Is that easy to integrate? Thank you. We're not there yet. What's the remainder? So it's 2 over u minus 1. Now, Why did that make you laugh?
U minus 1, like u minus 1.
All right. Later I'm going to kick myself that later when I catch on.
You're like, put 2 over u minus 1.
Yeah, I'm not getting closer. I want to. All right, let's integrate this before I feel really dumb. I'm just math smart. I'm not like real, like worldly smart. Okay, so integrate 2. What do you get? 2u. Make that simple. What is this right here? And recognize, do you know that 2 can actually be written in front of the integration because this is the constant. And when I look and go, okay, what's the derivative of u subtract 1? The derivative is, it's set up, right? And what is that? It's going to be a logarithm. So it's 2u plus 2, and what goes inside the logarithm is u minus 1. And don't forget the candy. And then what's the last step? What does u equal again? So wherever there's a u, what do I put in? X to the 1/2. Or you can put in root x, equivalent. And it's over. Yay, Mr. G Math is awesome. Over and out.